These your ciliary muscles, they are basically proteins contained, and the proteins, they become like less in it, right? So once they become deproteinized, they do not have any proteins. Obviously, if the muscles, they do not have their energy, what will the muscles do? They will become to die. Once they become to die and die, then obviously this whole space that is contained this muscle, this will be empty. Once this is empty, no images will be produced here, and the image will be formed unclear and blurred. So this, when there is degeneration or death of the protein part of the ciliary muscle, then the person suffers from a thing that is called as the cataract. And how you can treat a person with a cataract is that then the lens becomes unuseful. You cannot see images either close, either far. For example, this close image, if your protein has been degenerated, you will not be able to see the pencil. So if you're unable to see this pencil, what will be a disease that will result in a cataract, and its treatment will be that you will have to get a new lens which will have a high nutrition of protein, and then ciliary muscle, your suspensory ligaments, and then image will be formed and the person will be able to see again. Okay. Now, the visual activity. The visual activity is basically the activity of the eyes to see the objects, right? And the objects, they should be placed at a distance of 1 millimeter from one another. When these objects are placed at a distance of 1 millimeter from one another, when these rays will pass from these objects, they pass through the lens and they reach at the fovea of the retina. Now, at the fovea of the retina, these rays coming from these objects should be placed at a distance of at least 2 micrometers from one another. Now, why they should be placed at a distance of 2 micrometers from one another? Because then we can be able to see that these are two different objects. For example, this is my one pen, right? And this is my second pen. Now, the light rays coming from this pen and this pen, they will be a distance of 2 micrometer at my retina, and then I will be able to know that, oh, this is one pen and this is one pencil. But if they come exactly below 2 micrometers, we will think that this, instead of two objects, it is only a single, and we will not be able to differentiate them. Okay? Then how we know the distance, how far your object is? That is done by depth perception, which is that method of the eye or the optics or the lens to tell us how far an object is or how close an object. And it depends upon these three different factors. Number one is the determination by the sizes. For example, this is my object, right? If this is present at a near image, you can see, for example, its height will be like, I think, 3 inches something. So if I see it here close to me, I will be easily able to identify. And if I even place it at a far, by looking at its height, I will be able to know that this is a pencil added. So that is the first thing in it, where we can do it by depending upon the size, we can able to see the image formed at the fovea of the retina, and we can able to identify the different objects. The second is the distance of it. For example, if this is right, if this is present close to me, like if this is me, right, and this, or I can see this is me and this is the book, and it's present close to me, and if now I look here, so obviously the book that is present to me will look with me. And if that object that is present, that now that is a distance more than, so even if I rotate myself, that image will not rotate so with me so fastly as an object that is present close to me. So the less the distance, the more fast the image will be formed at the fovea, and the image will be cleared. But the less more distance far it is, then the less it will move with the object, and the less image you will be able to see. Okay. Then you have third, that is done by your determination of distance by the streptosis method, binocular vision. Now, what happens is in a binocular vision that, for example, let me show you here. You have this person, right? This is a person, right? Now, when this person, this is his eyes and this is his nose, he puts his finger on his nose and he closes one eye. So he will see an image here. Now, when he will close this eye, he will and see the image from here, he will feel a shift in that image. This shifting of image from one side to another side, from the right side to the left side, is called as your streptosis binocular vision. Okay? That is just about this one. And that's about it. Okay. Alright, now we're going to study about the two types of fluids that are present in the eye. Here present on the outside you have a free floating fluid that is called as your aqueous fluid, and on the posterior surface of the lens you have a fixed fluid that is called as the vitreous humor fluid. Now this is fixed, whereas the aqueous humor, it can be formed continuous. Now what is the function of these two fluids? Is the transport of the nutrient from the eye or to the eye. Okay, now how the this flow occurs from the aqueous humor, how this fluid it is passed from the ciliary bodies all the way into the vein. First of all, it is going to pass from the ciliary bodies into the anterior surface of the lens. From the anterior surface of the lens, it is going to go and enter into the space that is present between the iris and the cornea. From there, they're going to drain into this canal of the, what is it called? Scalum. From the canal of the scalum, they're going to drain into your trabeculae, which are present here. You can see here, these are the trabeculae. These are the trabeculae, and from their canal of the scalum, they're going to drain into the trabeculae, and these trabeculae basically consist of the aqueous humor. That is why they're called as the aqueous veins. Now that is all for the drain. And they also have a pressure, and that pressure is called as your intraocular pressure, and its range is 15 mm but a millimeter per mercury, but its range is 12 to 20. And if its values increase more, then you can suffer from glaucoma. Alright, so that was all for this chapter of the special senses on the eye part 1. That was the optics of vision. Hope this helped you guys and made it easy. If you have any questions, leave it in the comment box, and do like and subscribe for more videos. Thank you.